All right, so as you can see, we got a couple problems up on the board, and the blue one, it's tricky. I'm not gonna lie. Okay, so go ahead and write that one down, and then the one in the upper right-hand corner, that's gonna be a little bit new as well, and we'll explain why that is in just a moment. One of the things that you're gonna find, especially when you get to college, okay, maybe not so much at high school. One of the things I try to always keep in mind, it's a good idea to always challenge your minds because we always want to keep moving forward. And hopefully with this, we're combining information that you're hopefully comfortable with and learning something new that goes with that. Now, I can't speak for everyone in this building, but that's what our reasoning for that is, and that's what we do in here. So other classrooms, that's up to the individual teacher, and they probably do the same. I mean, that's what I would guess. So let me know when you have them two compounds wrote down. Okay, so maybe we can't have you on camera then, but you can be heard, just not seen. That might be a calming effect for Mr. Tom. Is that what you would like? Well, then I can't post it. That's a stipulation on the Science Channel, is you can't have minors on there. No. Well, I don't know how picky it is. Maybe if you just walked across, I mean, that might be something different as opposed to walking up and saying, "Hey, Tom." No, none of that. But I don't know. You got 30 seconds. That's what you. We gotta. You see, I can't speak for all men and all women either, but you see, that would kind of contradict on why women get frustrated with men because my theory is when the good Lord told men to line up for your brains, we thought, oh, he said line up like a train. See, that selective hearing kind of gets you too. That might explain a lot, right? Maybe yes, maybe no. Okay, so, hmm. Okay, well, we'll just go in order. What do you think the blue is? Okay, so Jordan, we'll start with you. What do you think the blue is? Give me the parent chain that you think. Actually, I meant to cut this one off, to cut him off. Sorry. I actually had two of them up there, said, I got to cut that one off. I didn't cut enough off. Now, this is why it could possibly be tricky now. Okay? Now, one of the aspects with this, okay, when you say that parent chain, okay, what do you think it's a straight or a branched chain? It is a straight chain. Now, this is why something like this could be a little tricky. Okay, this is the part where we're kind of challenging to try to talk on my end. This is where we're trying to challenge you in your thinking abilities, because one of the things that I heard a math teacher say this years ago. The more coming out of high school, the more you know, the less you have to learn. Now, does that make sense to you? In other words, the wider base this is what I interpret, the wider base that you have here the less time you have to spend learning that in college. So the more you know, the less you have to learn. So when we look at this, you would probably want 1, 2, 3, 4, 5, 6, 7. No one would disagree with that. I would find that hard pressed to disagree with. But you may have done one of these, 1, 2, 3, 4, 5, 6, 7, thinking, well, that's a branched chain. But in your mind, why can that, I would say, why can that not be a branched chain? Yeah, because if you make this a branched chain instead of a straight one, if you go up and over, well, how do you name those derivatives if you go up and to the right? So that is correct. Okay, so now you got the hard part out of the way. So we already established that this is heptane. Okay. So now okay, so we've got a C, we've got an I, and okay, right. So we don't want to go by the T part. So there's nothing wrong with doing this. Okay, and then you can just look at the letters for these. It's a little different when you have something like that. You wouldn't. With these, it's just the name of the element. You're not going by carbon. That's methyl instead. But if it's a halogen derivative, you can just go by the letter that you have here. That's right. So, who's coming first? Okay. So we've got, and this is the hard part, trying to visualize how much space you actually need. So 3 dash T butyl, okay, dash what? See, and iodo. I guess you don't need that dash there. Iodoheptane. Okay. Now, it could be, we can throw another, this was a curve, maybe we'll throw you a slider next time. Okay. So let's say we take this guy out and then do something like this. Okay. The only thing, you got to change 2 things on that. We got to, first of all, this is, I don't know what that T is doing there. You have to get rid of that suffix. Okay, so now we've got heptene. Okay. Okay. Now, one of the things to keep in mind, you did that exactly right. This is going to be more important next chapter. Okay, because notice that after each one of these letters, let's just go home.
Yeah, I'm with you. I'm so out of it right now.
Preaching to the choir. Okay, so notice that after each one of these numbers, you have the derivative and where it's located. But there's nothing written after this 2. So when you do that, and when you put a number and nothing comes after that, you're designating where that double bond is located. Now that's going to become more important even next chapter when you may put an alcohol group on here. Because then you're going to actually put a number here in between the suffix and the parent chain. But we're not ready for that yet.
So it has to be because double bonded carbon and an alcohol. Like tack on an alcohol. How is that?
Okay, so we'll put them right here.
Yeah.
Okay. Well, then what you're doing is this is still after the second one. Oh, that's not right. Heptene-4-all. So then what you're doing, so when you reverse engineer this, let's go back to what we had it as, which was this. Okay? To me, this is always the best way to look at it, I think. And so you can always, if you want to say, check your answers. This is telling you your organic family. Okay. This is telling you your parent chain. So when you see this ENE, that's saying, okay, we've got an alkene, so somewhere there's a double bond. Okay? There's nothing written after this 2, so after the second carbon, there's a double bond. There it's located. That's what that's saying. Here it says there's an iodo group. Well, where's that iodo group? Well, it's on the second carbon. There it is. Okay? This says there's a chloro group. That's on the first carbon. There, that one is. And here we see a T-butyl group on the third carbon, and there that is. So it's one of them things to where sometimes you're crunched for time, but if you can always go back and check to see, okay, that's what that would be correct then. Okay, and I think it's worth your time to go over the other ones. So how would we change that to from a tertiary butyl group to a secondary? That's the easiest one.
Okay, so put 1 down, carbon, 1 to the left, and then 2 to the right.
Okay, so then the first thing you're going to always want to do, sometimes say, well, X marks the spot there. Again, this is a carbon-to-carbon bond, and we've got a 4-carbon derivative, so we know it's butyl, and since it's on the second one, we know that's secondary butyl. Okay, so SB. So now, how do we change this butyl group to a isobutyl group now? Okay, now that will become more important, especially when we get to our amino acids. And you'll like that in the spring for 2 reasons. 1, it's proteins. 2, you're knocking on the door of getting out of here for almost the last time. We're coming up with again, we're trying to slowly break you into this because you're going to experience a lot of lasts your senior year. Okay, so all right, so that does it for naming these. You're going to see that on your exam tomorrow. Okay, so this one's a little more tricky over here on the right. Okay, because here we're going to start being a little more specific, and we'll show you what that means here as you write. I suppose I can still use the black marker. Okay, so it's a ring structure, so we got to have this cyclo on here. Okay, and then your derivatives are where and where. Okay, so it doesn't matter which one you start at, whether it's this one or this one. For the most part, to me, it's always been easier to go clockwise when you're naming it, if you can. So upon doing that, I guess you're going clockwise regardless, whether you're going there, I guess. But okay, now notice how are those 2 methyl groups oriented? They're not. Do you remember dealing with spin in your quantum numbers? Okay, so very quickly we'll do pick a number between 5 and 10. 6. What a coinky dink. Who's element 6? No. Carbon. That's a coinky dink. Yeah. Okay. Okay, so here's your quantum numbers, kind of a little bit of review. So we know that this is 2, and then what block is it in? Okay, now one of the things, follow your bus seat rule now. How many arrows does it get?
4?
It gets 2. Yeah. Because you've already done the 1s2 and 2s2 already. Yeah. So there we go.
No.
Why is that not right?
We taught you anything.
Oh, okay. So what's wrong with this?
Yeah.
What rule we got? What rule do we have to follow?
The busty.
Well, that's true. How? What's a better? That's a better name for it. What's the real rule? Starts with an A. Afabu. Yeah. Okay. So this guy's pointing up too. Okay. So we know that N is 2, L is 1, and M is what? 0. But then the spin. Yeah. See the thumbs up or thumbs down? So it's a what type of half? You have a 50-50 choice. Is it positive or negative? It's positive. Are you positive? Yes, that's right. Okay. All right. Which is good because you're going to have to recall that information a year from now. So what I tried to explain to them is now, let's say SDSU has been in classes now, this is maybe their 4th week. It's our 5th. It's their 4th. I would venture to believe that they're probably doing stoichiometry already. We don't get to stoichiometry until what? Until January. That's what we start with. So you're compressing all that information down into a semester rather than a year. So you don't have to worry about that. But yourself, that's gonna be, we're trying to get you ready for that. So regardless. Now, what do you notice about how these are oriented? Like thumbs up and they're going in opposite directions is what I'm trying to tell you. Okay? So according to your vocab quiz, what did that say about that stereoisomerism?
Oh, it's trans.
Right. So this is trans then. So if this one was pointing up instead, then it's not trans, it's rather what? Cis. CIS. Okay? So when we do that, we know that our derivatives are at 1, okay, and 3. And they're pointing in opposite directions. So therefore, like you correctly said, it would be 1, comma 3 dash, no, not yet. Dimethyl, you got to put the di in there. Okay. And it's one of them things to where we do that, so then the next time, hopefully it doesn't. It happens, okay? Just like we say with your mistakes. 2 things, of course. Try to learn from them and try not to repeat them. Okay, so now we've got 1, comma 3 dash dimethyl trans. That trans is in the wrong spot. Goes over here. Yep. Yep. Well, I would tend to agree, so hopefully they choose to do that. Now, I don't know, but how many... So that wraps that portion up. You have just naming compounds, drawing them, isomers, and the reactions. Okay? So, do you think you need a quick refresher on the reactions, or are you good? Okay. So, right and right. Okay? Well, I'm going to shut the tape off at that time. All right. So give me an alkane. Okay, so what do you want to react that heptane with? Okay, so we're gonna. Darn, I always forget to switch colors. So I always think it's just easier to see that way. So there anything wrong with writing it like that? No. You can do Cl2 if you want, but what happens is, and these could be story problems too, to where it could say what happens if an organic chemist takes heptane and reacts it with chlorine. What two products would you get? So now, we're going to say that you're going to create the products. So our next step in this reaction has to be what? Have to have some UV light or some heat. Okay. Now, there's going to be two products with that. So let's keep them really, really simple. So what would the first one be? Which is a relative term, so you want left or right. Okay? And that's probably would be the most common spot. Then in between there, we would also put, now if you put plus HCl, that's fine, but it's also going to form what else in an equal amount? Right. Okay? Now, this is, I'm kind of glad we're doing this because this sets the stage for some of your addition reactions later on this week. Because it's, this name will roll right off the tongue. It's called Markovnikov's rule. Okay? Something like that, yes. So, where do you want me to put that chlorine? Okay. So, those would form at about equal amounts. And again, so if you were paying attention, why don't we write plus? You can. Why would you not have to write plus HCl? Yeah, it's known. Organic chemists aren't concerned with that byproduct. So if you want to be the type that I got to write that in, that's fine. But we're not going to beat anybody up over that. Okay. Oh. Okay. One, two, three, 4, 5, 6, 7. It's not the best, but always make that bigger on the bottom. Okay, so what are we reacting this cycloheptane with? Okay. Yeah, that's kind of hard to draw, I know. So plus. Okay, so then what else do we do? Okay. Mm-hmm. Yep. Oh. Oh, I see what you're getting at. What I think you would do, okay, is on the second time. No, not necessarily move it. Kind of came short there. Put them here. Put them there. But with ring structures, let me check that quick. I find it hard to believe that you would do that twice. I'm thinking it's just the one, too, now that I think about it. I do believe you are correct when you say that. Just let me double check that. Yeah, there's just one. You just draw it once, not twice. Yep. Okay. Way on the bus, left side, or just, I guess I didn't even need to say that. But, okay.
That's such a big class. After taking time.
I know. It's a challenge. It can be. No, I'm just kidding.
I understand.
So, very good. So, we will catch up to you next time.